What if I told you that the most familiar substance on Earth, the thing you drink every single day, is quietly breaking the rules of physics? Not in some sci-fi way, not in a lab experiment, but right now, in your glass, in your body, everywhere. And when Richard Feynman looked closely at it, even he, one of the greatest physicists ever, basically said, this doesn't make sense. So the question is, what is water hiding? Let's start simple. Almost every substance in the world behaves in predictable ways. Heat something up, it expands. Cool it down, it contracts. That's just how atoms work. They move faster when heated, spread out, take up more space. Easy. But water? Water decides to do something completely different. Imagine filling a bottle with water and putting it in the freezer. As it cools, it does what you expect at first, it shrinks. But then, right before freezing, something weird happens. It suddenly expands. It takes up more space as it becomes ice. That's why ice floats. That's why frozen pipes burst. And that alone is already strange, because almost nothing else behaves like this. But wait for it, this is where it gets deeper. If ice didn't float, lakes and oceans would freeze from the bottom up. Over time, entire ecosystems would collapse. Life as we know it probably wouldn't exist. So somehow, this weird behavior of water isn't just random, it's perfectly tuned for life. Now you might think, okay, maybe it's just one-off property. But no. Water keeps going. Water has an unusually high heat capacity. That means it can absorb a lot of heat without changing temperature much. Think about the ocean. It absorbs sunlight all day, stores massive amounts of energy, and releases it slowly. This stabilizes the climate of the entire planet. Without it, temperatures would swing wildly, scorching hot days, freezing nights. Life would struggle to survive. And then there's surface tension. You've probably seen insects walking on water like it's solid ground. That's not magic. That's because water molecules cling to each other more strongly than almost any other liquid. They form this invisible skin on the surface. It's so strong that small creatures can literally stand on it. So now we have a liquid that expands when it freezes, stabilizes global temperatures, and forms a surface strong enough to hold life. Already unusual. But the real mystery lies deeper, in the way water molecules interact. At the microscopic level, water is made of H2O, 2 hydrogen atoms and 1 oxygen atom. Simple, right? But the way these molecules stick together is anything but simple. They form what are called hydrogen bonds. These are weak compared to chemical bonds, but incredibly important. Here's the strange part, each water molecule is constantly forming and breaking these bonds with its neighbors, trillions of times per second. It's like a chaotic dance, always shifting, never stable. And yet, out of this chaos emerges stability on a large scale. Feynman once pointed out that even though we can write down the basic laws that govern these interactions, predicting exactly how a bunch of water molecules will behave together is insanely complicated. In fact, it's one of the reasons fields like fluid dynamics are so hard. Think about it. You can describe a single water molecule pretty well. But put billions together, and suddenly you get waves, turbulence, currents, patterns that are incredibly difficult to predict precisely. It's like going from knowing how one person walks, to predicting the motion of an entire crowd in a stadium. And this is where it starts to feel unsettling. Because physics is supposed to give us clear, predictable rules. If we know the laws, we should be able to calculate what happens next. But water challenges that idea. It follows the laws, but the outcome becomes almost impossible to compute in detail. Feynman loved pointing out this gap between knowing the rules and understanding reality. He essentially said, yes, we understand the basic principles, but when it comes to something as simple as water, the complexity explodes. Now here's a thought experiment. Imagine you had the most powerful computer in the world. You program in all the laws of physics, every force, every interaction. Then you ask it, simulate a glass of water being poured. Not approximately, perfectly. Every molecule, every motion. Even today, That's practically impossible. Not because we don't know the laws, but because there are just too many interactions happening at once. The system becomes overwhelmingly complex. So in a strange way, water exposes a limitation of physics. Not in the laws themselves, but in our ability to use them to fully predict reality. And then there's something even more fascinating. Water seems to exist in a kind of balance that shouldn't be so stable. The hydrogen bonds I mentioned earlier are constantly breaking and reforming. At any given moment, the structure of liquid water is fluctuating wildly. Yet somehow, it maintains consistent properties: density, temperature, behavior, flow. It's like a crowd of people constantly changing positions, yet from a distance, the crowd looks stable and organized. That kind of emergent behavior is one of the deepest mysteries in science. And it doesn't stop there. Water also has an unusually high boiling point for such a small molecule. Based on its size and composition, it should be a gas at room temperature. But it's not. It stays liquid, again because of those hydrogen bonds holding everything together just enough. If you step back and look at all these properties together, it starts to feel less like coincidence and more like something finely balanced. Almost as if water is sitting right on the edge of multiple physical possibilities. Too little bonding, and it would evaporate easily, no oceans, no rivers. Too much bonding, and it would be solid most of the time, no flowing liquid, no life as we know it. It's right in the middle. Feynman found this kind of thing fascinating, not because it breaks the laws of physics, but because it shows how strange and unexpected the consequences of those laws can be. You can have simple rules, and yet the results can feel almost designed. But they are not. They emerge naturally. And that's the disturbing part, if you think about it. Because it means the universe doesn't have to be simple to be understandable at the basic level. It can be governed by elegant equations, yet produce behavior that feels unpredictable, messy, even mysterious. Water is a perfect example of that. It obeys every rule, and still surprises us. So the next time you pour a glass of water, remember, you're not just holding a liquid. You're holding a system so complex that even the greatest physicists couldn't fully predict its behavior in detail. A substance that quietly shapes the climate, supports life, and challenges our understanding of how simple rules turn into complex reality. And maybe that's the real lesson here. Not that water breaks physics, but that physics, when pushed to its limits, reveals just how strange the universe really is. If you enjoyed this, make sure to like the video, subscribe, and let me know in the comments what other everyday mysteries you want to explore next. Because sometimes, the most ordinary things are hiding the deepest questions.